Since the first seed was planted thousands of years ago, farmers have continued to select, breed and grow better and healthier crops. From the mid-20th century, scientists have been constantly looking for ways to develop new and improved plant varieties to meet the demands of the growing population and to address issues such as reducing dependence on agrochemicals, depleting natural resources like water, and challenges posed by climate change. Conventional methods of plant breeding have played a vital role in developing new seeds for increasing food production. However, in the wake of climate change, which is adversely impacting Indian agriculture, we need technologies that can reduce environmental footprint and make agriculture more resilient to climate stress. Since the discovery of DNA as the basis of all life, our knowledge of plant genetics and genomics has enormously increased. Scientists have developed the ability to link genes to specific characteristics of an organism. Consequently, we have entered the era of targeted breeding that allows us to make precise and specific changes efficiently in the plant genome, thereby considerably reducing the time and effort in the breeding process. These new breeding innovations, such as genome editing, permits desired changes in the DNA much more efficiently as compared to the conventional tools of plant breeding, and thus facilitates developing new varieties with complex traits, such as resistance to multiple abiotic stresses like drought, heat, and flooding. Importantly, plant breeders are now equipped to combine traits like climate resilience, resource use efficiency, and higher nutrition in a single crop variety.
Genome editing has emerged as a game changer and has huge potential in contributing significantly to food security, climate resilience, nutrition security, and sustainable development. Research has shown that certain genome-edited crops are similar and indistinguishable from the ones developed through random mutagenesis or naturally occurring mutations. And there is no foreign DNA present in the final product. In fact, two such genome-edited crops like tomato and soyabean have already been approved for commercialization. Globally, we have witnessed an unprecedented revolution in the use of genome editing technologies, not only in agriculture, but also in health and pharma sectors, including developing diagnostic kits and vaccines for COVID-19. In India, we must use these novel technologies in crops like oilseeds and pulses for raising productivity levels and for developing new varieties resistant to heat, drought stresses, and pests and pathogens. Efforts are already in progress in India for developing new genome-edited crop varieties, both in public and private sector laboratories.
Freshwater scarcity, rising day and night temperature, increasing soil salinity are the major problem for rice cultivation. Hence, the target traits include genetic improvement in water use efficiency, nitrogen use efficiency, grain quality, and productivity under abiotic stress conditions. Currently, we are working on improvement of water use efficiency and drought and salt stress tolerance in rice by using genome editing. With the funding support from National Agricultural Science Fund of Indian Council of Agricultural Research, we have developed genome-edited mutants of drought and salt tolerant genes in a mega rice cultivar MTU 1010. This mutant is free from foreign DNA and it uses about 25% less water and tolerant to drought and salt stress. This is expected to increase water productivity, nutrient productivity, and yield under drought and salt stress environment.
With rising incomes and changing food habits, consumption of edible oils has been rising over the years. India heavily depends on imports to meet 2/3 of its edible oil demand, which is worth 61.56 thousand crore rupees as seen in 2019-20. The use of advanced biotechnological approaches like genome editing will provide novel opportunities for both improving productivity and reducing the oil import of the country in near future. Using the CRISPR-based genome editing, my lab is focusing on improvement of nutritional oil quality through the development of transgene-free canola quality mustard lines. We have developed improved lines showing precise editing of multiple candidate genes that are involved in glucosinolates and fatty acid composition in Indian oilseed mustard. In addition, we are also working on number of parameters of biotic stress which continuously threaten and impact the productivity of this important crop. Thus, gene editing tools provides us with several opportunities for raising the productivity levels as well as oilseed quality of oilseed mustard in the global market.
Application of innovative new breeding approaches such as genome editing is important for the nutritional improvement of banana. Banana is an important crop in several developing countries, including India, where it contributes not only to household food and nutritional security, but also for income generation as a cash crop. The application of conventional breeding for genetic improvement of banana is difficult due to the technical reasons. Hence, we are applying genome editing to overcome vitamin A micronutrient deficiency, which is the leading cause of preventable blindness, growth retardation and decreased immunity. We have successfully edited a gene of carotenoids biosynthesis pathway in banana for enhanced accumulation of beta carotene required for vitamin A synthesis in humans, that is up to 6-fold in the fruit pulp as compared to unedited control plants.
We must fully realize the potential of these innovative technologies for addressing serious concerns of malnutrition and adaptation of crops to the fast-changing climate. We need science-based regulation and the support of policymakers for ensuring profitability to the smallholder farmers and for ensuring environmental sustainability. If it is positively received, India stands to gain globally through the use of these genome editing technologies for achieving sustainable developmental goals of the United Nations by 2030.